Techshop is a membership-based, do-it-yourself studio and fabrication workshop. We sell memberships for $100 a month, and you get access to 15,000 square feet of every machine tool, woodworking tool, digital prototyping tool, you name it, we've got it. We'll show you that you do this quick little tour. We do memberships. We teach classes on all the equipment, so introductory classes so that you won't hurt the machine and the machine won't hurt you. We're very much a do-it-yourself culture, so we basically introduce you to the basic usage of the machine, and then you're on your own. Go for it. Have a lot of fun. We have 5 revenue streams: membership, classes. We have a retail store over here. We do short-run manufacturing on spec and by order, and then we also rent studios out to startups. So this is the open bay. We have 12 large, big tables. We believe that every kitchen table should come with a vise and compressed air, electricity, and wireless. And since most kitchen tables don't, you can come here. We have this is called our bin wall, and this is stuff that people have donated from out of their offices and their garages, and it has everything: circuit boards, CD drives, antennas. My favorite one, I don't know where it is at the moment, is a box of rocks. So you can get a GPS transceiver and a rock if you need it. This comes from the idea from this came from the Mythbusters, and anytime that you needed a little project or something, you were able to go into the bin wall and get it. Our founder, Jim Newton, was the science advisor on Mythbusters for their 3rd season. Solved all kinds of real-world problems like how many ping pong balls does it take to refloat a yacht? That was one of his projects. It turned out it was 500,000. They modeled that one. They didn't actually buy 500,000. This is one of our sexier machines over here. This is a 3D printer. It uses ABS plastic strands, melts them down, and spits them out into 3 dimensions. What's nice about this is ABS is a target manufacturing plastic. When you produce a part like this, it has about 50% of its tensile and shear strength that you would get in a molded piece. So this is a finished piece. This is kind of cool because you couldn't possibly mold this in one shot. So that's kind of what it's demonstrating here. This is the project halfway done. It creates a scaffolding material that's a starch base and dissolves away when you put it in a hot lye bath, and then this prints this up in 3 dimensions. Now, why this is important? There are a couple of things that this is emblematic of. So this is a pepper shaker made out of ABS plastic. 10 or 15 years ago, if you decided that you wanted to go to a retailer with a prototype of something like this made out of plastic, you would have needed to get a CAD/CAM machine that cost about $10,000 in hardware, $8,000 to $10,000 in software, an operator who could actually produce something for you. You would then take that file and ship it off to a machine shop who would then cut it in aluminum. The odds are he would cut it wrong because you didn't envision something correctly. It typically takes 2 or 3 cuts before you get something that you want. You then take it to an injection mold shop and you order 5,000 of them because it's basically just as cheap to get 5,000 as it is one between the setup costs. And you now have 5,000 of these in your garage, and you're ready to then go to the retailer and say, hey, look, I got this great looking pepper shaker. Would you like one? How many would you, I don't want to order a bunch of them. And he would probably say, wow, that's great. You know what, I'd really like it with 4 holes. And so you would cut the aluminum again, you would produce it, you would ship it to them, and net, you would be into this for 6 months and $60,000 to $100,000. We call that a significant barrier to innovation, knowing that it's going to cost you $60,000 to $80,000. I feel badly if you've actually done it once, and it's sitting in your garage, and your spouse can then beat you about your head and shoulders the rest of your life about how brilliant of an innovator you are. That's actually what happened. Today, You can download Google SketchUp for free. You can create the model, run it through an interpreter that will create what they call an STL, a stereolithography file. You can ship it to us. You don't even have to be a member. A couple of $100 later, you've got your part. You clean this up, you blister pack it, you ship it off to a buyer at the appropriate retailer, and you can go from concept to prototype to order in 30 to 60 days and for a few $100.
But if you want to put it into mass production, I mean,
well, then you have to cut steel and you do injection molding. But you've got your production prototype that actually looks like, feels like what it is that you're trying to sell. The manufacturer has a number of case studies where people have actually done that. They've gone from concept to production, prototype, order, and then they actually went to steel and cut it and produced it. That is new to the world. Again, 10, 15 years ago, you couldn't do that. And what this is very cool. This is a 3D scanner. And so what you do, and it's about $5,000. Again, 10 years ago, it was a $250,000 machine, and you only saw it in high-end automotive design firms. You basically didn't see it anywhere else. This is about $5,000, and what you do is you put your target scan there, fire the computer up, lasers go in and scan it, creates a very nice 3D file, which you then port over to the printer, and you produce your part that comes out in ABS plastic. And that's actually how we got this part. We scanned that part, shipped it over to the machine, printed it out. Now what you can do with this is you could sand cast it and pour aluminum mold, pour aluminum in here. This would dissolve out and you would get back to your original part. Jay Leno uses it to reproduce Duesenberg parts that are no longer in production. He uses actually this type of machine, scans it in, prints it out, and then converts it into aluminum or steel or whatever it is he needs. Great tool, very powerful. Again, 10 years ago, there's no way in the world you could touch this for any reasonable amount of money. Got a basic tool set. What's cool about this is when we opened it, we thought there might be theft, or in retail they call it shrinkage. And what happened actually was the inverse of the problem of the commons. And there's a nice Pulitzer Prize in economics this year that talks about how commons actually can work. This is a physical embodiment of it. All these electronics showed up. So the community got so excited about what's going on here, they figured they don't use these tools that often, and they gave them to the community. Same thing with these hand tools. We seeded the hand tools with about half of these, and then the other half just showed up. So, people had drills and other stuff, and so they decided to bring them in, which is very cool. We call this the hub area. So we've got a food area, free popcorn, free coffee, refrigerator, sugar rush stuff from Pepsi, and then 4 computers that have all of the software that you need to drive the machines that are computer controlled. We purposely have the screens facing in because we want people to shoulder surf and exchange ideas. The odds are your intellectual property is not going to get stolen. It will actually be upgraded. And we have a number of case studies where people have come out here and other folks have donated IP that they've actually embedded into the products. So open source is a very interesting and cool thing, and we do that here on purpose.
You mentioned before you're not an incubator.
No.
I mean, you're not involved in it. Why are you not involved in these companies?
Because I don't want to, so I don't want to choose. Part of our DNA is we love makers, and we love all makers, and I don't care what your project is, we like it, and we want you to come in and do it. If you're a true incubator, VCs have, they look at 5,000 deals, and they turn down 4,970 of them. And that's if it's a big year for them and they actually do 30. We don't want to be in a position where we have to choose which children we like, which makers we like, and so we don't. If you got $100, you can come. You want an office, it's $1,000. It's kind of open source, crowdsource. You figure if you've got the money to be able to spend to innovate, you can come here and give it a try. And we're not going to judge what it is that you're doing. We'll let somebody else do that. So that's why we don't play that game. This is a finishing room. We have a hood up above for light spray. then a powder coating oven and a powder coater, so you can get what appears to be a finished powder coated aluminum whatever off the manufacturing line. This is the laser cutter room. We have a laser cutter class going on right now.
And the idea here is just to give you a chance for pushing the buttons, getting familiar with it, and making mistakes while we can help you figure out what it is, so that you can come back and do it on your own.
So this laser cuts plastic. It cuts wood, paper, leather. It etches glass. We've had a lot of people start eBay-like companies here, card companies. Our monkey DNA sequencing guy used it to build some of his prototypes. It's a very powerful tool, extremely easy to use. We call it our entryway drug because once you've used it, you're hooked. 10 years ago, this tool set would have cost you $3 to $5 million. We're able to do it for about 500,000, so that's one of the major trends. The Chinese and computers have forced capital costs of equipment down so rapidly in the last 10 years. We're now able to do something that was economically infeasible literally a decade ago. So those machines are about $25,000 each. We have 2 of them here. We'll have 3 of them in San Francisco. You probably, if you're going to start your little eBay business, you're not going to buy it because it's too expensive. So how do you make 100 of these to put on your little website to figure out whether or not other people want it? You know, until you had a service bureau like what we're providing, or you could actually come in and do something like this, it wasn't possible. So, you know, they're a huge barrier to innovation. You don't get to do it because it's simply too expensive. Now, for $100 and a $45 class, you can produce your first versions of it, you know, get a 1995 website, e-commerce site, and start spamming all your friends. And who knows, you might get a business out of it. Some people have. This is very cool. This is like the laser cutter. It's called a plasma cutter. And instead of cutting plastic and wood, this cuts steel. And as you can see, it will cut really nice, thick chunks of steel. The one we have in Durham will cut 3 inches of plate steel, and it cuts it like it's butter. So again, part of the objective here is you can build anything. I mean, you can come in, you got an idea, and you know, people use mills and lathes to build scanning tunneling microscopes. You could do that here if you wanted to. We have people that are building GNA sequencers here. We have people doing all kinds of crazy stuff because we have all the tools in one place to be able to do it. So this is our basic machine setup. We got a finger brake, corner notcher, hole punch. We make all of our own washers because we can. Why buy a washer when you can make it yourself? So this thing, you know, punches little holes in metal just like that. This is about a $10,000 machine. This is an English wheel, which does compound complex curves, enables you to be able to do, you know, bumpers and rail guards and other types of things. Planishing hammer. This is a tube bender, so you can build go-karts, race cars, motorcycles, bicycles, a complete welding setup, welding shop. Cut-off saws. This is our complete woodworking area. So a little bit of disarray. We just got a new machine over there that we're getting ready to install. This is kind of the sexy new tool. It's a computer-controlled woodworking CNC machine. It's got a 5-inch throw on it, so it can do up to 5 inches thick of wood. And my favorite story with this one is we had a member come in, and he convinced his wife that he could spend $100 a month if he did a calla lily for their front door out of wood. Evidently, calla lilies played a major role in their wedding, and so this 25th wedding anniversary is coming up, and she said, I'll let you be a member if you can put calla lilies on the door. Has no experience in CNC machinery, never done anything like it, says, sure, I'll give it a try. Takes 2 classes, our Introduction to CNC Concepts, CNC for the ShopBot, downloads a calla lily off the internet, loads it up, scavenges this enormous piece of oak. I mean, it was like, it was probably 6 feet tall and 4 feet across, off the freeway that had flown off some big truck. And it was like an inch and a half thick. Slaps it on, test cuts. Actually, I think this is it. Makes a couple of test cuts, blows it up, builds a calla lily, brings in his target material, and does a calla lily for the front door. And then she likes it so much, he completely does all the cabinets in the house, and then all her friends come over and say, "Hey, I want roses. I want all of it. I want all this other stuff." So he stopped at that point. He's like, "No, I'm just doing it for my wife." But the point here is 2 weeks, a couple of classes, and you're building custom calla lily cabinets for your wife. Again, new to the world. 10, 15 years ago, what do? You hire a cabinet maker. He charges you $5,000 to do it. You sit in the backyard and whittle it with a knife. I mean, there's no other way. You need access to these kinds of tools. 10, 15 years ago, the computer to be able to run this would have run you 10, 15 grand. The software was actually in the $100,000 range, and these tools were $250,000. It would have taken almost $500,000. The software tools were hard to use, so you'd need 4 to 6 months of dwell time on the software to get something out of it. It was completely and totally inaccessible to the Pro-Am. It simply couldn't be done, and now it can. We had a former General Electric general manager come through here. He ran the train engine division at GE, and he pointed at this is called a DRO, or a digital readout, and he said, 15 years ago, I spent $100,000 on a DRO that looks just like that. I spent $250,000 on the machine. How much did this cost you? $4,200 installed. $250,000 to $4,200. So 98% reduction in cost. That is huge. It's almost like a Moore's Law type of thing. Same thing here. This was a $250,000 machine 10 years ago. It's now about a $20,000 machine. This, again, the software was $100,000 a decade ago. The software was easier to do than assembly, but harder to do than C++. So, if you had 6 months of time and skill, you could kind of make it do stuff, but you really needed to be a skilled operator and be able to program directly in what they call G-code. Now you can use Google SketchUp to get the first draft. You can import it into these types of software, which run us about $10,000, hook it up to a $17,000 machine, and literally, again, in 2 or 3 weeks, you too can be producing three-dimensional objects. So let me tell you a story about a guy. So a guy comes in, one of our staff members says, "Hey Mark, you got to go meet Mike." So I go over, "Hey Mike, what are you making?" He says, "Oh, I'm making a desktop diamond manufacturing device." "Oh, a what?" "A desktop diamond manufacturing device." "Really?" "Yes." And he holds up this very poorly milled block of aluminum. It looks bad. He says, "Yes, this is my pressure chamber." I go, "Really?" "Yeah. This is the port for the hydrogen. This is the port for the methane. This is the viewport so I can see what's going on the inside." "So, well, how does it work?" He says, "Oh, it's easy." "Right." Like, okay, this guy's either crazy in a good way or crazy in a bad way. I need more information. So, "Mike, how does it work?" He says, "Well, what you do is you go out and get a magnetron from a used microwave." And I'm thinking, a used one. A brand new one's what, $300, and you need to go out and save a couple $100 on a diamond manufacturing device? He says, "It's good enough." So he says, "Yeah, you fire this up and you pump in the hydrogen and you pump in the methane and you put in a whole bunch of pressure and a plasma ball forms and diamonds fall out." "Right. And I'm going to do that this weekend." It's like, "Great, Mike, you're doing that at home, I trust." He says, "Oh yeah, all the equipment is at home. I'm going to do it at home." Well, 2 or 3 weeks later, I see him again, and he's got a new pressure chamber. Actually, it looks really, really good, and the viewport looks pretty serious, and he starts bringing in samples of little diamonds that he's making in his garage. Now, he happens to have a PhD in physics, had started a diamond tool deposition company in the past, But he knew to build his little pressure chamber, it would normally have cost him $80,000. And so he was out golfing and playing tennis and drinking Starbucks until he found Techshop and figured for a couple $1,000s he could learn how to use the machine, mill the blocks himself, go find a used magnetron out of a microwave, and start making diamonds in his garage. And that is in fact what he's doing. It cost him $2,000 instead of $80,000. New to the world stuff. This is the sewing textile room, and we have an embroidery machine that does embroidery, computer controlled embroidery on caps, t-shirts, and a couple of industrial strength sewing machines. I consider this kind of one of those non-obvious rooms that Jim, our founder, was just a genius in realizing. And the way he realized it was he said, I've got 200 ideas of products that I want to do, and so he just started listing all the equipment he needed to finish a particular project. And when he got to one that needed a leather bag or he needed upholstery, so I need industrial strength sewing machines, and he put it on the list. And it turns out if you're building an electric car like 3 people have done here, and you want to redo the upholstery, you need an industrial strength sewing machine to redo the leather or the vinyl. If you're working on a sail, you need the tools to be able to do it. So these are industrial strength machines. You see people in here all the time doing cool stuff. This is a plastics lab, as we call it. This is a extremely useful machine, little known. It's called a vacuformer. And what you do is you put in a heat-sensitive polymer ply sheet. You can see it's got some stuff on the wall. And you heat it up so that it's flexible. Put your target mold in it, and then you suck all of the air out, and it produces these little plastic components. A lot of children's toys actually use vacuforming in their manufacturing process, and then a lot of computer components, the bezel for computers, a lot of stuff are done actually with the vacuformer. It's a very powerful, again, not very well-known machine. But between the CNC machine, which can cut some foam out very fast, you slap it in here, heat it up, bang, you've got masks, you've got components for cars, you've got all kinds of very interesting stuff. This is a vinyl cutter. It's primarily used for making signs, but you can also use it to make masks for t-shirts or PCB boards or other types of things. Grinding room. It's kind of our dirtiest room. We've got a sand blaster for finishing metal up. We've got a grinder here, a tumbler, finishing wheels. All the stuff that you need to finish off metal or plastic. And then this is our car bay. We briefly came through here. So people work on their motorcycles, their automobiles. We've got the jack stands and all that stuff. And we've got a fenced yard out back for storage and stuff. So that's mostly, we've got one more. And this is a room that we give away to anybody who has any kind of remote connection to making or engineering or creativity. So arts clubs meet in here, the Boy Scouts, Girl Scouts. Singularity University came through. We didn't charge them for the room, just brought them in. The Transhumanist Society meets here. The Artificial Intelligence Group meets here. The Innovators Alliance Group meets here every month. And again, we just give it away because it's great PR and we love makers. So that's basically 15,000 square feet, like I said, of every woodworking machine, tool, plastics tool to make just about anything you can possibly imagine for $100 a month. Life is cool. So.